we're going to work through this set of ideas, this set of topics, geostatistics. You thought geospatial was the only thing that we could attach geo to. We can basically attach geo to anything. Go broader than that. Think of a word or an action or a noun or anything, and add geography to it, and you've got your own area of study. Sports geography, music geography, all of these things, real things you could study and explore. Geostatistics, same idea. Geostatistics and modeling. We are thinking about spatial statistics specifically, and really some fundamentals about these topics. How we take a statistics-based understanding of spatial patterns, how we apply that to spatial thinking, spatial sampling, spatial mathematics. It ties into modeling. Everything in GIS is a model. We've been there. This is all linking some various pieces together. And we're really starting with statistics. When we say statistics, we're talking about the same type of ideas that you would take in a math class or a stats class. Distributions, arrangement of data. When you understand how your data is arranged or distributed, you can understand something about the nature of your data. Does your data have a normal distribution? Does it have a power distribution? You know, all these things that maybe once upon a time you remembered, but you always look up anyway. I always do, at least. Someone says, oh, well, I've got Poisson data. I'm like, yes, I definitely understand what you mean. And I'm Googling it in the background to make sure I remember which curve it is. That's okay. Just equally okay is knowing that spatial data has similar characteristics. Spatial data has the same types of distributions, the same ideas of arrangements, and that plays out in a lot of different ways. For example, we could have points. Here are some points. Look at those lovely point files. How those point files are arranged, or how they are spaced, how they are structured. Pick your favorite word that you like. How they look. That's as good of a descriptor as any for this type of stuff. How our data is operating, how our data is functioning, gives us an understanding of how this data was either made or influenced. Now, a regularly spaced structure like this, with these points that are clearly set up to be every certain amount of distance in this grid, certainly suggests some influence of structure, I would say. Maybe it's aliens, but it's something. Or maybe it's a normal, natural process. Some atoms look like this. The distributions of our data give us a clue into how that data might either operate, might have been sampled, might have been created, any part of this. Here's some random points. Maybe nothing affects that. Here's some clustered points. Something is going on here. Now, this could represent a lot of different information, these points. This could be in an area, and we went and we sampled all trees of a certain species. And when we map them all, we say, hey, all these trees are clustered together. Something must be affecting the distribution. Or we could have something like this regular spacing and say, okay, I went out and made the sampling grid because I want to look for temperature data. And I'm setting up a lot of temperature sensors. But maybe too many temperature sensors. Whatever it is, we can put this type of work into either collecting data, or this could be data that we gathered, data we observed, data we sampled. And just like we have correlations in our distributions and our data sets, when we graph them, we can have distributions and correlations spatially as well. This is the outputs of one of the spatial tools inside of ARC, nearest neighbor analysis. Throw a bunch of points in there, see if there's a spatial relationship of those points. See if there are any correlations between how the points look and operate. In this case, for the points that were thrown in here, it was random. Maybe it was just a randomly generated set of points. Maybe it was something else. Maybe someone sampled all the snails or birds or whatever it might have been. And oh, it's random. No connection. Maybe it's could be anything. Could be any spatial data that we've sampled. We might want to understand what is the relationship in that data. Now, these point locations then come from all different kinds of places. And so another side besides going out and looking or collecting data or sampling things is then also how to collect things. How do we set up camera traps? How do we build records? How do we find really angry sheep to put a GPS collar on? Works for this data, it could work for a census. Who are we going to ask to fill out the extra fancy bonus American Community Survey census? Who are we going to find to see if there is some kind of, maybe we're sampling for diseases, or maybe you're trying to understand something about cat behavior. We could try to understand any kind of sampling approach through a similar type of analysis. Here's some points. Stare at this. What's gone into the construction? Say we're field sampling. Doesn't matter what those colorful zones are. This could be air pollution monitors in a city, maybe. Maybe this is some kind of regular grid, some kind of regular pattern adjusted for landscape parameters. But something pretty standard. Or maybe we're doing a sample of convenience. Maybe those are roads and we don't want to, wander off into the wilderness. We're going to set up our camera traps for taking pictures of cute, fuzzy wild animals along the road. Maybe that's how it goes. Or maybe it's like, we're going to go survey people. And this is where the people were hanging out, in the park, around the hiking trails. We're going to go do surveys, and this is the location where we surveyed them. Ask them questions about, I don't know, something going on in the park. All of these sampling techniques, all of these sampling questions could lead to different results. Could lead to different answers, could lead to certainly different data sets. When we're thinking about statistics, when we're thinking about sampling, when we're thinking about the work that we're doing in a spatial sense, we have to think about what goes in and what goes out of data that has a spatial component. And that's where spatial statistics tools can be helpful for us. Because we also have to think about scale. We also have to think about how much or how little we're looking at. We'll continue that chain of thought in the next video.